If every bee on Earth vanished tomorrow, you wouldn't starve immediately. You'd starve slowly, over about 4 years, as the food system quietly collapsed behind the scenes, while most people were still arguing about whether it actually mattered. That gap between cause and consequence is exactly why this threat gets underestimated. What would actually happen, step by step, if bees disappeared completely? Start with a number that surprises most people first. Bees are responsible for pollinating roughly 1 out of every 3 bites of food you eat. Not because every crop needs them directly. Staple grains like wheat, rice, and corn are wind-pollinated and don't rely on bees at all, but because the fruits, vegetables, and nuts that make up the more nutritionally diverse part of your diet depend heavily on pollinators. Apples, almonds, blueberries, coffee, chocolate. Technically, since cacao trees rely on tiny midges rather than bees specifically, but the broader pollination network, bees, anchor supports far more of your plate than most people realize. Remove bees, and you don't lose all food. You lose the food that makes your diet interesting, and arguably, the food that keeps you healthy. Now consider almonds specifically, because they're the clearest real-world preview of what a bee collapse actually looks like in practice. Almonds are almost entirely dependent on bee pollination, with no viable wind or self-pollination alternative at commercial scale. Every February, an estimated 2/3 of all commercial honeybee colonies in the United States are trucked into California's Central Valley specifically to pollinate almond orchards, because the natural bee population in that region alone could never handle a crop that size. This already happens every single year as a direct response to bee populations being too fragile to rely on without intervention. If that logistical operation ever failed at scale, almond production wouldn't decline gradually. It would collapse within a single growing season. Here's where the timeline actually starts to matter. In the first few months after a total bee disappearance, you likely wouldn't notice much change at all, since most fruits and vegetables already growing would still make it a harvest using existing pollination that had already occurred. The real disruption begins the following growing season, when new crops fail to set fruit at anywhere near normal rates. Farmers dependent on pollinator-heavy crops would face immediate, severe losses, and many would likely shift toward wind-pollinated staple crops out of necessity, simplifying diets worldwide almost overnight. Within a few years, sustained across multiple failed growing seasons, prices for fruits, vegetables, and nuts would climb dramatically due to scarcity, making those foods a luxury rather than an everyday staple for a large portion of the world's population. It's not just about your dinner plate, either. Wild ecosystems depend on bees just as heavily as agriculture does, arguably more, since wild plants don't have human farmers stepping in with backup pollination strategies. An estimated 80% of all flowering plants globally rely on animal pollinators, and bees are the primary pollinator for a significant share of them. Remove bees, and entire wild plant populations begin declining within a few growing seasons, which then affects every animal that depends on those plants for food or habitat. It's not a single collapse. It's a chain reaction, moving outward from plants to insects to birds to larger animals, each step depending on the step before it. Consider what happens to other pollinators during all of this, because bees aren't working alone even now. Butterflies, moths, certain beetles, and even some bats and birds pollinate plants too, and in a world without bees, some of that lost pollination work would likely shift to these other species by default, simply because the plants that survive would be the ones those alternative pollinators can still reach. But bees are uniquely efficient at pollination compared to almost every other pollinator species, partly due to specialized body hair that collects and transfers pollen far more effectively than most alternatives. Other pollinators picking up the slack wouldn't come close to replacing bees at the same scale or efficiency. You'd be trading a highly optimized system for a much less efficient patchwork of substitutes. Now think about the economic side of this, because the numbers here are almost as staggering as the ecological ones. Economists estimate that pollinator services, the vast majority attributable to bees specifically, contribute somewhere in the range of hundreds of billions of dollars annually to global agricultural output. That's not abstract. That figure represents actual crops that would either fail entirely or require expensive, labor-intensive manual pollination as a replacement. In parts of China, where pollinator populations have already collapsed in certain regions due to pesticide overuse, farmers have resorted to pollinating fruit trees by hand, using brushes to individually transfer pollen from flower to flower, an incredibly slow, expensive process that gives you a small, real preview of what manual pollination at global scale would actually require. Coffee deserves its own mention here, mostly because of how personally this would hit an enormous portion of the world's population. While coffee plants can self-pollinate to some degree, research has shown that bee pollination significantly increases both the yield and quality of coffee crops. A bee disappearance wouldn't eliminate coffee entirely, but it would shrink supply and quality simultaneously at the exact moment global demand for coffee continues rising. Combine reduced almond production, reduced fruit diversity, and reduced coffee quality, and you get a genuinely different, more limited relationship with food than most people currently take for granted. So why does this threat feel so distant to most people, despite how severe the consequences actually are? Partly because bee population decline has already been happening gradually for over a decade, through a combination of pesticide exposure, habitat loss, disease, and a poorly understood phenomenon researchers call colony collapse disorder, and gradual decline rarely triggers the same alarm that a single dramatic event would. You don't panic over 4 years of quiet decline the way you'd panic over an overnight extinction, even if the eventual consequences land in exactly the same place. If every bee on Earth vanished tomorrow, you wouldn't starve immediately. Now you know the countdown would already be running quietly behind almost everything you eat.